Okay, so let's have a look at how we do molar calculations. This basically is how we work out how many moles we have from the mass of substance. Or, if we want to look at the other way, we can work out from how many moles we have of something what the mass will be. So let's have a look at calculating substance. Basically, what you need to remember is that the molar mass for something, the unit is grams per mole. And if we want to know, we can actually use that as our guide. If we want to know how many atoms we have, we can use the mass of it. Now remember, moles is essentially the number of atoms. It's like a dozen, except instead of being 12, so 1 dozen is 12. If a dozen eggs are 12, if you've got a mole of eggs, you've got 6.022 times 10 to the power of 23 eggs. Okay, so it's how many atoms there are. We can use this formula here. Moles equals the mass divided by molar mass. And what happens is when you divide those out, they cancel out. It just gives you how many moles you have. So the way you actually write this is you write N, that's the symbol for moles, equals mass divided by molar mass. Now there are two other ways to write molar mass. You can write it with just a capital M. My capital M's are not neat enough, so I usually write it like this, which is also correct. Or you can call it the formula mass. All three are correct, and you will see all three. The equation can also be rearranged to work out the mass of the substance. And it would look like this. So if you knew how many moles you have, and you know what the molar mass is because you can look that up on the periodic table, you can work out what the mass is going to be. So for example, mass equals moles times molar mass. And that's just rearranging this equation. So to clear out, so you want to get this on its own, this means you multiply both sides by big M. And that means this one here, which is also big M, would cancel out. So it's mass equals moles times molar mass, or mass equals moles times molar mass. Let's have a look at an example, and we'll show you. Oh, sorry, I skipped ahead there. Let's have a look at an example. We'll skip backwards. If you want to calculate the moles present in 17.01 grams of graphite. Graphite is an allotrope or version of carbon, so it's just carbon. So the first thing we do is we write down the appropriate equation, which in this case is moles. That shows that we're calculating for carbon, that little c. So moles of carbon equals mass divided by molar mass. Next thing we do is we write down our knowns. So we don't know how many moles we have. What we do know is we know the mass and we know the molar mass, because we looked this one up and this one was weighed if you're doing this in the experiment. Now it's really simple. We just plug in the numbers into the equation and we solve it. 17.01 grams of carbon divided by 12.01 grams per mole. If we then cancel these out, that would give us 1.416 moles of carbon. Now, it then says 4 significant figures, which is we have because of that. That's 4, that's 4. That's our lowest number of significant figures. We're not quite finished yet. We've got one more step, and that is write our answer statement. Therefore, in 17.01 grams of carbon, or graphite, there is 1.416 moles of carbon particles, or moles of carbon is fine. Alright, I hope that made sense. If it didn't, ask any questions in the comments below. We'll get back to you as quick as we can. Thanks for watching. See you next time. Bye now.